All right, last segment. Kind of got to go into a fourth segment as we ran out of time. Just going over the equations that you'll need to be able to work out your last two worksheets on circular motion. Talked about centripetal acceleration on the last one at the very end. It's v squared, which is your tangential speed, your linear speed, divided by your radius that you're going around. And then your centripetal force is going to be mass times that acceleration that you decide. So all you're doing is taking that and multiplying mass. Once you find the centripetal acceleration, your force is fairly easy. To find your tangential speed, though, sometimes they don't give it to you, sometimes they do. Remember, that's not how many revolutions per second you're doing. It's meters per second in a linear way, but you're going around in a circle. Normal velocity, distance divided by time. But because we're moving around in a circle, your distance has to be found by a circumference, 2 pi r. So now we got to figure out what that circumference is, dividing by the amount of time, depending on if it's a revolution or not. So there's two new terms in here. One is the idea of a period, and that's capital T. I know capital T, lowercase t. It comes a little bit. Lowercase t is time, regular time, and then capital T is going to be period. That's the amount of time it takes you to make one complete revolution. One complete, if you're talking about harmonic motion of swinging back and forth, it's one complete cycle is still considered a period. And how can you find that? The frequency is the number of revolutions per time. So a number of waves there are per, like time. It's a frequency is the same whether you're talking about waves or circular motion. Is how many revolutions per time. And you can convert between one or the other just by going 1 over. So period is 1 over the frequency, and frequency then is 1 over the period. Not a lot of questions get into those things, but some things that you would use your centripetal force. Car going around a curve, it's going to be the friction that's causing it, still the force. Orbital motion, what's making an object go in orbit is the force is going to be gravity, but that would be considered your centripetal force. A circular room, such as a carnival ride, we'd call that just the normal force holding you in. And then the mass on a string, if the tension it is, if you were that can on a string as you spin it around, it would be the tension would be considered your centripetal force. They all just different ways of saying centripetal force. So if you have any questions, this being new stuff, make sure you look at the full PowerPoints, additional videos that are on there. Be sure to look at that physics classroom. It's a different site. That's got a lot of good stuff on centripetal motion. Look up circular motion. Any questions, though, feel free to email mark.boer@addisonschools.us, and we'll see you next week.